This is
Millions
the
of
car
people
deemed
trusted
unsafe
these
at any
cars with
speed.
their lives.
One
They were
sharp turn
sold by
could
some
cause
of
the
the
rear wheel
world's
to
biggest
tuck, sending you into a
manufacturers,
violent roll.
marketed as safe, reliable,
beautiful,
and ready for
lethal piece
everyday
of history.
families. But hidden beneath the paint, some carried engineering flaws that would trigger lawsuits, massive recalls, government investigations, and forever change automotive safety. These are the most dangerous cars ever sold to the public. The automobile transformed the world. By the early 20th century, cars had become symbols of freedom, progress, and opportunity. Families could travel farther than ever before. Businesses expanded, cities grew. But while engineers focused on making cars faster and more affordable, very few people asked a simple question: what would happen when those cars crashed? For decades, most vehicles built with almost no dedicated safety features. There were no airbags, no crumple zones, no electronic stability control. Even seatbelts were uncommon in many passenger cars until the mid-20th century. Drivers often sat behind rigid steering columns, surrounded by hard metal dashboards and sharp interior components. In a serious collision, the car itself could become the greatest danger. As engines became more powerful, roads improved, highways stretched across entire countries. Cars traveled faster than ever before, yet vehicle safety engineering struggled to keep pace. Crash testing was still in its infancy. Manufacturers often focused on styling, horsepower, and production costs rather than occupant protection. The consequences would become increasingly difficult to ignore. By the 1950s and 1960s, traffic fatalities had become a growing public concern. Researchers, doctors, engineers, and journalists began studying why so many crashes were proving fatal. They discovered something important. Many deaths were not caused by the crash alone, but by preventable design weaknesses inside the vehicle. That realization marked the beginning of a new era in automotive safety. Not every unsafe car was the result of negligence. Many reflected the engineering knowledge and industry standards of their time, but some designs would later become the center of controversy, recalls, lawsuits, and lasting changes to the automotive industry. These are the stories of the cars that reshaped safety forever. By the late 1950s, American car buyers wanted something different, smaller, more economical, and easier to drive. General Motors answered with an ambitious design, the Chevrolet Corvair. Introduced for the 1960 model year, it broke with many American traditions. Instead of a front-mounted engine, the Corvair placed its air-cooled engine in the rear. It was one of the most unconventional cars ever built by a major American manufacturer. The Corvair's layout offered several advantages. Without a large engine in the front, it provided a flat floor, improved traction over the driven rear wheels, and a unique driving experience. Many owners appreciated its innovation, but its unusual suspension design also attracted criticism. Early models required careful tire pressure maintenance and could behave unpredictably if improperly maintained or driven aggressively. In 1965, a young lawyer named Ralph Nader published a book titled Unsafe at Any Speed. The opening chapter focused on the early Chevrolet Corvair. Nader argued that aspects of the car's suspension design created avoidable handling risks. The book quickly became a national sensation. For the first time, millions of Americans began questioning whether automobile safety received enough attention from manufacturers. The debate had begun. The controversy reached far beyond one automobile. Government officials launched investigations. Engineers re-examined vehicle design standards. General Motors defended the Corvair and later introduced suspension improvements on newer models. Years afterward, studies, including one by the U.S. transportation authorities, found that the 1960-1963 Corvair's handling was broadly comparable to other contemporary compact cars when properly maintained. Even so, the public conversation about automotive safety had already changed forever. The Chevrolet Corvair became more than a single controversial car. It became a turning point. The discussion it sparked helped accelerate improvements in crash testing, vehicle engineering, and government oversight. Whether viewed as misunderstood innovation or flawed design, its impact on automotive history is undeniable. By the late 1960s, the American auto industry faced a new challenge. Small, fuel-efficient imported cars were rapidly gaining popularity. Ford needed an answer, and fast. The result was the Ford Pinto, introduced for the 1971 model year. The project moved from concept to production in an unusually short time, reflecting intense competitive pressure. It was designed to be affordable, practical, and economical. Millions would eventually be sold. Soon after the Pinto reached the road, questions began to emerge about its fuel system. Investigations focused on the location of the fuel tank behind the rear axle. In certain high-speed rear-end collisions, the tank could be damaged, increasing the risk of a fuel leak and, in some cases, a fire. It's important to note that not every rear impact crash resulted in a fire. The concern centered on specific crash conditions that exposed a design vulnerability. As serious accidents received national media coverage, the Pinto became the focus of lawsuits, engineering reviews, and public debate. Consumer advocates demanded stronger safety standards. Journalists questioned how manufacturers balanced cost, speed, and engineering decisions. The controversy extended far beyond one model. It became part of a larger conversation about corporate responsibility and vehicle safety. In 1978, Ford announced a recall affecting approximately 1.5 million Pintos, one of the largest automotive recalls at the time. Engineers developed reinforcement measures to better protect the fuel tank in rear impacts. The recall marked a turning point. Automakers across the industry began paying far greater attention to fuel system protection and rear impact crash performance. The Ford Pinto remains one of the most discussed automobiles in automotive history, not simply because of the vehicle itself, but because it accelerated changes in engineering, regulation, and public expectations. Modern cars are now subjected to rigorous rear impact testing, fuel system integrity standards, and extensive crash validation. Many of those improvements were strengthened by lessons learned during this era. By the mid-1980s, American drivers were falling in love with a new type of vehicle, the sport utility vehicle, compact, affordable, and capable of going places ordinary cars could not. One of the most popular newcomers was the Suzuki Samurai, small, lightweight, and remarkably capable off-road. It quickly developed a loyal following. The Samurai was designed first and foremost as a compact off-road vehicle. Its short wheelbase, narrow track, and high ground clearance made it exceptionally agile on rough terrain, but those same characteristics also influenced how it behaved during sudden steering maneuvers on paved roads. Like many vehicles of its class, its handling characteristics differed significantly from a conventional passenger car. In 1988, a widely discussed report from Consumer Reports concluded that the Samurai showed a higher tendency to roll over during certain emergency avoidance tests. The publication advised consumers against purchasing the vehicle. Suzuki strongly disputed both the testing methods and the conclusions. The disagreement sparked years of legal battles and intense public debate. Regardless of who was right, the Samurai had become one of the most controversial vehicles of its era. The controversy raised a larger question. How should rollover risk be measured? Automakers, independent testing organizations, and safety regulators began refining evaluation methods for SUVs and light trucks. Vehicle stability, suspension tuning, and rollover resistance received greater engineering attention. The debate helped shape future safety standards across the growing SUV market. Today, the Suzuki Samurai remains a symbol of one of the automotive industry's most public safety debates. Its story reminds us that vehicle safety is not determined by a single headline. It depends on engineering, testing, driver expectations, and using each vehicle within the environment for which it was designed. By the late 1990s, sport utility vehicles had become America's family vehicle. Among them, the Ford Explorer stood at the top of the market. It offered space, comfort, and the confidence of four-wheel drive capability. Millions were sold. Few owners imagined that a growing safety crisis was beginning to unfold. Transportation investigators started noticing a pattern. Some Firestone tires fitted to certain Ford Explorers experienced tread separation. In some cases, especially at highway speeds, a sudden tire failure could make the vehicle difficult to control. Because SUVs have a higher center of gravity than most passenger cars, a loss of control sometimes increased the risk of a rollover. Investigators worked to determine why these failures were occurring. As reports accumulated, federal safety agencies launched formal investigations. Engineers examined tire construction, vehicle dynamics, road conditions, and maintenance records. The crisis quickly expanded beyond one company. It raised important questions about tire manufacturing, inflation pressure, vehicle design, and quality control throughout the automotive industry. In the year 2000, millions of Firestone tires were recalled. The recall became one of the largest automotive safety actions ever undertaken. Ford and Firestone eventually ended a partnership that had lasted for nearly a century. Manufacturers responded with improved tire testing, more rigorous quality standards, and stronger monitoring of real-world safety data. The Ford Explorer and Firestone crisis transformed automotive safety. It accelerated improvements in tire durability, vehicle stability, and consumer awareness. Today, modern vehicles benefit from tire pressure monitoring systems, stronger tire standards, and more advanced stability technologies. Many of those improvements were shaped by lessons learned during this difficult chapter in automotive history. Sometimes, the most serious engineering failures are hidden inside the smallest components. In the early 2000s, General Motors introduced several compact vehicles equipped with an ignition switch that, under certain conditions, could move out of the run position. If that happened while the vehicle was in motion, engine power could be reduced or lost. In affected vehicles, this could also disable power steering assistance, power braking assistance, and prevent airbags from deploying in a crash. A component no larger than a few centimeters had become the center of one of the industry's most significant safety crises. As crashes were investigated, engineers began comparing damaged vehicles, ignition switches, and crash data. Government agencies, independent experts, and General Motors launched extensive reviews. In 2014, GM announced major recalls covering millions of vehicles worldwide. The case prompted widespread discussion about product safety, quality control, and how manufacturers identify and respond to potential defects. While the ignition switch investigation continued, another crisis was unfolding across the automotive industry. Airbags manufactured by Takata had been installed in vehicles from numerous brands around the world. In certain vehicles, some inflators could rupture during deployment, sending metal fragments into the passenger compartment. Not every Takata airbag was affected. The risk depended on the inflator design, manufacturing period, and environmental factors such as prolonged exposure to heat and humidity. The scale of the problem was unprecedented. The Takata crisis eventually led to the largest automotive recall ever conducted. Tens of millions of vehicles across multiple manufacturers required replacement airbag inflators. Repair campaigns continued for years. Automakers coordinated with governments, suppliers, and dealerships across the globe. The crisis demonstrated how one supplier's component could affect an entire industry. It also accelerated improvements in supplier oversight, testing standards, and long-term quality monitoring. Modern vehicles are now designed with multiple layers of safety verification. Critical systems undergo extensive laboratory testing, computer simulation, environmental durability testing, and continuous field monitoring after vehicles reach customers. The GM ignition switch defect and the Takata airbag crisis became powerful reminders of one lesson. In automotive engineering, even the smallest component can carry enormous responsibility. Every controversial vehicle, every recall, and every engineering mistake left behind an important lesson. The Chevrolet Corvair raised new questions about vehicle handling. The Ford Pinto accelerated improvements in fuel system protection. The Firestone tire crisis transformed tire testing and quality control. The GM ignition switch and Takata airbag recalls reshaped how manufacturers monitor safety throughout a vehicle's life. Together, these events permanently changed automotive engineering. Today's vehicles are designed with safety at every stage. Engineers use computer simulations long before the first prototype is built. Thousands of virtual crashes are performed to evaluate how a vehicle will respond under different conditions. Only after extensive digital testing do physical crash tests begin. Every structural component is analyzed, measured, and refined. Many technologies now considered ordinary were once revolutionary. Three-point seat belts, crumple zones, anti-lock braking systems, electronic stability control, multiple airbags, automatic emergency braking. These innovations work together in fractions of a second to reduce the risk of serious injury for millions of drivers. They operate silently in the background every single day. Modern crash laboratories are among the most advanced engineering facilities in the world. Vehicles are tested from every angle: front impacts, side impacts, rear impacts, rollover protection, pedestrian safety. Every result is carefully measured using high-speed cameras and hundreds of electronic sensors. Safety is no longer an afterthought. It has become one of the industry's highest priorities. The most dangerous cars in history did more than expose weaknesses. They inspired better engineering, better regulations, and safer vehicles for generations to come. The road to today's safer automobiles was built on lessons that manufacturers could never afford to ignore. Modern vehicles are safer than at any other point in automotive history. Today's cars are engineered using billions of data points, thousands of crash simulations, and years of real-world testing. Many new vehicles can automatically apply the brakes, warn drivers of unseen dangers, and even help avoid collisions altogether. The difference between a family car built in 1960 and one built today is nothing short of extraordinary. Advanced driver assistance systems, better known as ADAS, are transforming how we drive. Automatic emergency braking, lane keeping assist, blind spot monitoring, adaptive cruise control, driver attention monitoring. These technologies don't replace the driver, they support them. In many situations, they can reduce the likelihood or severity of a crash. Yet no technology can eliminate risk entirely. As vehicles become more connected, new challenges emerge: software bugs, cybersecurity concerns, complex electronic systems, battery safety in electric vehicles, and the careful integration of partially automated driving features. Modern engineering has solved many of yesterday's problems, but every new generation of technology brings new responsibilities. Safety is a journey, not a destination. The Corvair, the Pinto, the Samurai, the Explorer and Firestone crisis, the GM ignition switch, the Takata airbag recall, each became part of a larger story, a story of engineering mistakes, public scrutiny, scientific investigation, and continuous improvement. Because of those lessons, millions of drivers today travel in vehicles that are stronger, smarter, and significantly safer. History remembers the most dangerous cars ever sold, not simply because they failed, but because they forced the automotive world to improve. Every crash test, every safety regulation, every engineering breakthrough is the legacy of those difficult lessons. The safest cars of tomorrow will be built upon the mistakes of yesterday. The crisis quickly expanded beyond one company. It raised important questions about tire manufacturing, inflation pressure, vehicle design, and quality control throughout the automotive industry. In the year 2000, millions of Firestone tires were recalled. The recall became one of the largest automotive safety actions ever undertaken. Ford and Firestone eventually ended a partnership that had lasted for nearly a century. Manufacturers responded with improved tire testing, more rigorous quality standards, and stronger monitoring of real-world safety data. The Ford Explorer and Firestone crisis transformed automotive safety. It accelerated improvements in tire durability, vehicle stability, and consumer awareness. Today, modern vehicles benefit from tire pressure monitoring systems, stronger tire standards, and more advanced stability technologies. Many of those improvements were shaped by lessons learned during this difficult chapter in automotive history. They operate silently in the background every single day. Modern crash laboratories are among the most advanced engineering facilities in the world. Vehicles are tested from every angle: front impacts, side impacts, rear impacts, rollover protection, pedestrian safety. Every result is carefully measured using high-speed cameras and hundreds of electronic sensors. Safety is no longer an afterthought. It has become one of the industry's highest priorities. The most dangerous cars in history did more than expose weaknesses. They inspired better engineering, better regulations, and safer vehicles for generations to come. The road to today's safer automobiles was built on lessons that manufacturers could never afford to ignore. Modern vehicles are safer than at any other point in automotive history. Today's cars are engineered using billions of data points, thousands of crash simulations, and years of real-world testing. But every new generation of technology brings new responsibilities. Safety is a journey, not a destination. The Corvair, the Pinto, the Samurai, the Explorer and Firestone crisis, the GM ignition switch, the Takata airbag recall, each became part of a larger story, A story of engineering mistakes, public scrutiny, scientific investigation, and continuous improvement. Because of those lessons, millions of drivers today travel in vehicles that are stronger, smarter, and significantly safer. History remembers the most dangerous cars ever sold, not simply because they failed, but because they forced the automotive world to improve. Every crash test, every safety regulation, every engineering breakthrough carries the legacy of those difficult lessons. The safest cars of tomorrow will be built upon the mistakes of yesterday.